project that we are going to do in our Milestone 5 and 6 is Serial Divider version 1. This is the shift left register A with a load and an enable. This component is used to store the dividend value and provide a left shift operations. Now we move to the waveform. We set the data A as 1110 and compile. So we can see that when the load is triggered, the data A will be stored in the dividend and the value will shift 1 bit to the left at every rising edge and hold when the enable is set to high. This is the data register B with an enable. This is the component that used to store divisor value. Now we move to the waveform. So this is the waveform. We set the data B as 0011. Now we compile it. We can see that when the enable is triggered, the data B will be stored into the divisor. This is the shift left register R with a load, an enable, and a 1-bit data input. This component is used to calculate the remainder value of divisions. Now we move to the waveform. We can see that the data will be shifted by D-in, which is the data input, and hold when enable is set to high. This is the shift left register Q with an enable and a 1-bit data input. This component is used to calculate the quotient value of the division. Now we move to the waveform. So this is the waveform result. We can see that the data is shifted by Qi, which is the data input, and hold when enable is set to high. This is the multi-bit adder. This component is used to subtract value R from value B. We set the primary carry in as high and inverted all the value from data B so that this adder can operate as a subtractor. This is the LPM counter. We set it as an up counter with a 3-bit white data and a modulus of 5. Besides, we also include a load, a count enable, and a carry output for this counter. This component is used to check the value validity by calculating the bit shifted. This is the overall circuit for the data path, which include all the components that we mentioned previously. Now we move to the waveform. We can see that when counter count to 4, which means all the data from data A is completely shifted, the result at remainder and quotients are 2 and 4. After complete the data path, we proceed to milestone 6, which is the control unit. At the left side is the height level ASM and the low ASM is placed at the right side. From the height level ASM, we can derive our next state equations, while from the low level ASM, we can derive our output equations. From the next state and output equations, this is the one-hop controller that we built. Next, we combine the controller units and the data path unit together into a complete system. Now we move to the waveform. So from this waveform, we can see that when we trigger go, the operation will start and stop when the counter reaches 4. To have a better view of the output result, we introduce a prescaler. We also introduce a converter that convert binary number to BCD so that we can use 7-segment display to show our result. So this is the compilation result. Now we're going to move to the simulation part.